Okay, hi guys. So in this lecture, we'll be continue seeing more on degrees of freedom. So let's get started. So in the last lecture, we'll be seeing degrees of freedom for a monatomic gas. So we also discussed that during at a very low temperature, we would only be considering rotational degrees of freedom. So we'll be continuing from that. So let's say what happens at ordinary temperature. So at ordinary temperature, we consider ordinary means at room temperature. We consider translational plus rotational degrees of freedom. Okay, and then at very high temperature, we consider translational plus rotational plus vibrational degrees of freedom, all the three. Okay, so for 1 mole of a gas, we can see that the contribution is that every translational degree of freedom contribution is kT by 2, or rather RT by 2. Every rotational degrees of freedom contribution is again RT by 2, and every vibrational degree of freedom contribution is RT. Okay, so this is at very high temperature when we are seeing for 1 mole of a gas what is the contribution of different degrees of freedom. Okay, so we can write that for monatomic gas, as n is equals to 1, so total degrees of freedom would be 3n, which is 3. Okay, so for diatomic gas, we can see that n is equals to 2, hence total degrees of freedom would be 3n, that would be 3 into 2, which is 6. And out of this, translational degree of freedom would be 3, rotational degree of freedom would be 2, and vibrational degree of freedom would be 1. Okay, now at room temperature we can say that CVM equals to 3 by 2R plus R. So CVM total would be 5 by 2R, and CPM would be 7 by 2R. Why? Because we know the relationship between CPM and CVM, that the difference of the two is equals to R. So just from CVM you can calculate CPM. Okay, and gamma would be 7 by 5. How is gamma calculated? We know that CVM would be equals to R upon gamma minus 1. So gamma can be calculated as R upon CVM plus 1. CVM is nothing but CVM is 5 by 2R, 5 by 2R plus 1, which would give us 7 by 5 as the gamma value. Gamma or 5, whatever I used for that. Okay. And at high temperature we can write that CVM would be equals to 3 by 2R plus R plus R. Why? Because we have rotational plus vibrational at very high temperature, and this vibrational was not there at room temperature for a diatomic gas, because at room temperature we only consider rotational plus translational, but at very high temperature we also considers translational plus rotational plus vibrational. So CVM in this case would be coming out to be 7 by 2R. CPM coming out would be 9R by 2, and phi value or gamma value, whatever you want to call it, would be 9 by 7. Okay. Next we'll be seeing for a triatomic gas we'll be calculating the degrees of freedom in the next lecture. So till then, good luck and goodbye.